Yes, yes. 1 second, 1 second. Just a minute, just a minute. Okay, yeah. This is fine, right?
Yeah, this is fine.
Or should I? Is it okay if I turn off the video, or is this fine?
Either one is fine. Whatever is comfortable.
Okay. Okay. So let's start.
Yeah. So you sent the link across. So can you just ping on your WhatsApp group? The links have been sent across.
1 second. Do you have the link? I have to take a minute. How do I send it on phone?
Okay. Permanent link. I'll
Just mail it to me. You can.
yeah. I'll send the link. Click on it. Click this link. Yeah.
One minute. Yeah, just a minute. Yeah, I've shared it.
Okay.
Yeah. I've shared the link in the group.
Got it.
Yeah, okay. So let's start, and I think people will join whenever they can.
Just hold on. I'll just try sharing the screen. Okay, you guys can share the screen. I mean, see the screen. Hello.
Hello.
You guys can see the screen.
Yeah, I can see it. I can see it.
Okay, so I'll while I answer the questions and explain stuff, I thought it'll be a good idea. I'll just go through some of the material online and point these things as and when I do it. That's okay.
Okay. Okay. Yeah, that's good.
Yeah. So the first question was that was put in the group was. In the simplest of terms, explain data science, machine learning, and artificial intelligence.
Yes, yes.
Yeah. So, where have you heard this term? Like, give me a one-liner. If you can give answer.
On Facebook advertisement recently, Cambridge Analytica, everywhere,
Okay.
right?
Yeah.
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 So the idea is.
Yeah.
So you can probably think of data science. You're able to see this, see the screen, right?
Hello. Hello.
You're able to see the screen, right?
Yes, yes, yes.
So when I say data science, I'm usually talking about statistics. So there's not much difference between the two. There are quite a few topics. So it's like a new nomenclature for the traditional subject that there was. And statisticians have their own language in which they speak. It's mostly derived from mathematical techniques. So that is something that is called mathematical statistics. So if I click there, you'll probably have mathematical analysis, linear algebra, stochastic analysis, and measure theoretic probability theory. You can point, when I'm pointing these on the screen, you're able to see it, right?
Yes, yes, yes.
Okay. So what does statistic constitute? Basically, there are two broad varieties. I won't call it varieties. Let's say it's there. It's right there on the screen. Descriptive statistics and inferential statistics, right? Descriptive statistics is you don't compute the characteristic of the data. Let's
Okay.
say, I mean, you don't take a sample and try to understand the mean and variance of the sample and try to infer something about the population as a result of that. You don't do
Oh,
that descriptive. You
okay.
just take the sample and understand the sample for what it is, and you don't infer that to any population. That is descriptive statistics. So
Okay.
this is something that people might be familiar with till now, wherein they would have studied this in high school and other avenues, wherein they would
Yeah.
study something about measures of central tendency, like mean, standard deviation,
Hello?
variance.
Yeah.
Me,
Yeah.
you're able to hear me?
Yeah. Yeah. Yeah.
Yeah.
Yes. 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 Hello?
So measures
Yeah.
of central
It's not
tendency.
clear.
It's not clear.
Yeah.
Just hold on.
Now I
Hold
can
on.
hear you.
Now it's better. So people who have studied about measures of central tendency, like mean, variance, and standard
Hello?
deviation. You're not able to hear me? Hello, you're not able to hear me?
No. 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 There's too much disturbance. I think it's coming from the other
Okay,
screens.
how
I think.
about
Yeah. Yeah. Now I
how
can
about
hear you.
now?
Yeah. Yeah. I can hear you now.
So, so I was talking about measures of central tendency. In this specific case, uh, mean, median, mode, and standard deviation variance, amongst other things. So once you do that, you would want to understand the implication of having studied the simple small sample on the
Yes.
larger population. Let's say math scores of girls and boys, or
Yes.
that'll be a weird example. Let's say math scores of 10 standard students and math scores of 9 standard students on the same
Okay.
test.
Okay.
Okay, you
Okay.
would assume, based on the maturity, based on the amount of work done, people in class 10 would be able to do well comparatively to people in class 9, right?
Yeah.
Obvious. I
Yes.
mean, all things being equal, you would assume that would be the case. But sometimes it is not the case. So you would want to understand why that is.
Right.
Okay.
Yeah.
So what you can do is you can probably, in this case, you will just take a uh, average score of people studying in class 9 and average score of people studying in class 10, and you would do a simple t-test, and if the values are significantly different, you would probably say that people in class 10 are significantly better than
Right.
people in class 9.
Yeah.
So this involves some level of study of distribution, because
Right.
to do a t-test, you would probably need to understand uh, whether the number of people involved in each one of the groups have, satisfy the sufficiency condition, wherein, like, are there sufficient numbers in each groups to be able to uh, you know compare them.
Okay.
So these are things that you would know in statistical theory.
Okay.
Okay,
Yeah.
so when I say inferential statistics, you would want to understand the general sentiment of people in terms of their choices for the upcoming election. If that is the question, uh,
Okay.
you would want to talk to, ideally you would want to talk to everybody who is involved, which
Yeah.
would not be possible, feasible, or logistically acceptable, because someone has to pay for people doing surveys.
Yeah.
In such a circumstance, your ideal strategy would be to take a sample which
Hmm.
would represent the entire population, and hopefully you'll get a fair idea, assuming that they've done the test well and the assumptions hold true and the assumptions are not compromised. You will get a fairly accurate idea as to who will win in the upcoming election.
Okay.
This is an example of inferential statistics.
Okay.
Okay, and I'll
Yeah.
tell you. So when people talk about forecasting or prediction, these are all direct derivatives of inferential statistics. Okay, there
Okay.
are.
Yeah.
Okay, I'll just go through the Wikipedia page. So sampling is an important topic.
Okay.
People want to understand the economic standard of any given city. They don't ideally they would want to talk to everybody, which isn't the case. So you take a sample and you hope that the sample represents the population. If that is the case, then whatever analysis you can do by studying, if there are 1 crore houses or what, let's say 10 million houses, you want to study all 10 million of them, which isn't the case. So you study about 1,000 of them, and you hope that 1,000 represent the population in every year. So by studying 1,000, you can make assumptions about, you can make advice, you can give advice to the government as to what kind of policy would help uh, would help the entire population. Okay. Hello.
Okay.
Uh, so
And
yeah.
yeah.
So then there is experimental and observational studies. These are things that they do in health sciences. Then there are types of data of, what kind, I mean, is it continuous, discrete, or categorical, these kinds of things. And each one of those types will have their own ways of analysis.
Okay.
So all this that I'm talking about. So again, this curve is very important, and whenever we say p-value, all that, I mean, you'll probably understand this curve better once you go through a course in statistics or data science.
Okay.
So this is about data science, right? So I
Yeah.
mean, it also has the history as to when it started. It's a very uh, young subject compared to other subjects, but it has quite a lot of significance because at least in the last 10, 15 years, because they're able to collect data. So the
Okay.
applications of it is quite evident. I mean, you can see on the screen. There are quite a few. And machine learning comes into the picture if you're able to put a feedback loop to all the techniques that uh, you have encountered in statistics and other things. So just if I Google machine learning, you'll probably get a Wikipedia page, just like the way you got a Wikipedia page for statistics. And there are lots of different applications around which they describe what this is. But basically, broadly, you can say there are two kinds of techniques: supervised and unsupervised. Unsupervised is you have a group of data that you want to see some sort of clustering. Okay.
Okay. Yeah.
Uh, so the ideal example is, let's say, what's the ideal example? Um, okay, traffic jams is unsupervised problem. Let's say there are lots of nodes. So this is again a graph. There are lots of nodes and or junctions around which there is a lot of congestion.
Okay.
Uh, you want to find that if you are able to if you're able to take a picture from the satellite and find out where there is a lot of clustering. Uh, I mean, if you are able to study it over a period of time, that will be like unsupervised learning.
Okay.
So you want to understand in the data that you're studying, where are groups formed, naturally occurring groups formed, naturally or let's say artificially occurring groups based on behavior that is formed.
Okay.
That is unsupervised learning. Supervised would be you have an outcome variable that you, let's say, you call y, and there are features or factors that affect this y. So this is
Okay.
similar to a regression model. So let's put that up. So let's
Yeah.
see. Oh, yeah. We're able to see what do I type?
Yeah. Yeah.
Are you?
Hello?
Are you able to see what I
Yeah.
typed?
I can see it. I can see it.
So, regression is a good example of a statistical technique whose which is sort of like supervised, wherein like you have a y and there are like some x's that affect. So simple regression is y and x.
Okay.
So y-axis represents the y that is the dependent variable, and
Okay.
x-axis is the independent variable. You want to find out how an independent variable x is affecting dependent variable y, and the line is the regression line. So that represents the slope.
Okay.
Okay, so
Yeah.
assume that if in the supervised learning case, if you have a categorical data like y, the y is a categorical data wherein it has a fixed state to it.
Okay.
You can use these techniques to find out uh, the features that affect the eventual outcome variable.
Okay.
Okay, so that would be,
Yeah.
I'll just take, so if you go back to machine learning again, then there are semi-supervised learning cases. Then there is a thing called reinforcement learning. Reinforcement learning is basically Markov decision process. They're called MDPs. So if I click this, I should probably get that. Let's see where they say MDPs. Yeah. So Markov decision processes. So there are lots of. There's a cost function usually. You want to be able to find out. So you have to be able to understand what the cost function is, and then you have to find an optimal solution for that. That is
Okay.
reinforcement learning. So even in game theory, you have something like that. There's an environment, then there is an agent. I think I gave this example when I met you, when I
Yes.
described
Yes.
it on the
Yes.
piece of paper. Yeah, so there's an agent and there is a reward system, which is sort of like an incentive system, and his action is adapted to the environment and the reward system. So the agent finds
Okay.
himself. So in that reinforcement learning, you probably have some numerical techniques, some procedures for discounted cost, Markov decision processes. So there is something called a long run average cost, Markov decision processes. These are techniques. So
Okay.
what they what they're used for is are scenarios in which incentive has to be fixed for agents. So
Okay.
let's take a telecommunication example. You have bandwidth that needs to be distributed. There is a central node which distributes bandwidth to a bunch of other nodes like houses. You want to be able to find out the right bandwidth to allocate to all the houses based on the amount that they have paid you.
Right. Okay.
Yeah, so this allocation is a good example for this. So I think
Okay.
it's right here. So
Yeah.
typical control problems are an example for this, in which there
Okay.
are agents at work. Then
Yeah.
you have lots of different techniques that I wouldn't want to go into. Temporal difference learning, and it's not there on the screen. Temporal differences in like you want to understand the behavior of these agents.
Hello.
Am I
Yeah.
audible?
Yes. 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 I can hear you now. Yeah.
So you want to be able to understand the incentive structure of this agents over a period of time, and you want to see how you're able to maximize the agent's behavior in such a way as to not maximize. Let's say facilitate the agent's behavior in such a way that you maximize the cost for which the agent is employed
Okay. Okay.
broadly.
Yeah.
Okay,
Okay.
so at this point, do you have any questions? I don't think I've given enough examples. Regression, I can probably think of a simple example wherein the birth weight of a baby is dependent on the birth weight of the mother and a few other
Right. Right.
things. So
Okay.
these cases are quite common in neonatal care. Neonatal care is
Okay.
care given to babies under the age of 20, I mean, within the first 28 days. So,
Okay.
uh,
Yeah.
so a lot of, I mean, that's a simple example. The major factor in the weight of the baby is the weight of the mother and her the nutrition that she takes in, and she has
Okay.
taken in for the last few months before the delivery. Delivery happens between 37 weeks to 39 weeks, and
Right.
there are a lot of the physics of the problem which determine the uh, what we call in statistics coefficient of determination, the R square value. R square value, which basically tells you how much an independent variable, in this case, the
Yeah.
nutritional intake of the mother, is affecting the weight of the baby. And
Right.
you
Yeah.
compare that, and so these are the beta coefficients, right? So,
Right. Yeah.
so when you get the beta coefficients, they represent the unit change of nutritional quality of the intake to a unit change of weight of the baby.
Right. Yeah.
Yeah, and you're able to measure it at a unit level. You can precisely, and then you put this in a feedback loop, and you test it to lots of new babies. And the uh, next time you encounter certain circumstances, you can clearly say what the weight of the baby ought to be, even before the birth of the
Okay.
baby.
Right. Right.
That's the
Okay.
prediction. That's the prediction part.
Okay. Okay.
So yeah, so where were we? We were in machine learning, and then we came to reinforcement learning, and supervised and unsupervised. Any classification problems are mostly problems related to supervised learning, wherein the y variable is a category. It can be two, it can be three, something like that. So,
Okay.
any questions at this point?
No, I don't have any questions. Hello.
Hello? Yeah, come again?
Hello.
Yeah,
Hello. Can you hear me?
yeah, I can hear you.
Yeah. No, I don't have any questions up to now.
Okay. So, history of the
Yeah.
field, which doesn't seem that pertinent at this point. We can probably, anyone can uh, Google this up and they will find lots of examples. Back propagation is something that I didn't talk about. This forms the backbone of all AI techniques, how, as to how back propagation works and how it was invented. The history of it is right here. In all these cases, there is some function, some loss function, whose gradient you need to calculate. Okay, and if you do it
Yeah.
over multiple layers, uh, it becomes a neural network of sorts. So all this is right here, so you can just click. So why is it called neural network? It kind of replicates, not it doesn't really mimic, but we probably have a better understanding. So we need to have some structure to these networks. So you might as well follow uh, a structure of biology in which signals are being passed around in these neurons. I don't know the
Okay.
biology aspect of it that well, but I don't think that's necessary for backpropagation, because backpropagation is based on that, but you don't need to know uh, the precise biology related to it. It's good to know, but
Okay.
even without it, we can survive. So reinforcement learning is something that and the role played by optimization. So all things in machine learning are a formulation of some sort of optimization problem. Usually, sometimes it's an unconstrained optimization, sometimes it's a constrained optimization. So, there is something called convex optimization. So, convex optimization is defined as optimizing a convex function over a convex set. or
Okay.
optimizing a convex function subject to a convex set. That's the right precise
What is a
definition.
convex set?
Okay, oh, that's a good question. So convex set is any. Okay, let's go to Wikipedia. It's easier. So convex set is, I'll just tell you so that you shouldn't feel like I Wikipedia everything. It's a good
No, it's
way
okay.
to visualize things. So convex set is any curve. Okay, let's define what a convex curve is, and ideally it should be convex set first and then convex curve afterwards. Convex set is if you take 2 points on a set, and
Okay.
let's say you find the middle point between those 2 points, that middle point will also be in the set. So the
Okay.
relationship is, let's say you have point A and point B, and let's say the ratio of distance between the middle point, let's say C, to A and B is lambda and 1 minus lambda. So the point C, so that's how you define it. If this condition is true, then the set is convex. So C is
Okay.
equal to A lambda plus 1 minus lambda B. If
Okay.
this is true, it's a convex
Uh-huh.
set. So let's
Okay.
see what Wikipedia says. So this is okay. Okay, so you see this? This is a convex set.
Okay.
See this? This is a convex set. This is not a convex set. So if you take a point X and if you take a point Y, if I take a midpoint of or some point in between X and Y, that has to be part of the set, which isn't the case here, which is the reason
Okay.
why it's not a
Not a
convex.
convex. Okay.
But
Okay.
this
Yeah.
is convex set. So why is this
Okay.
important? So this is ideally a convex function, but it's a set. I mean, convex function
Okay. Yeah.
is any function which has a positive curvature.
Okay.
You see the curvature that's positive. So like
Yeah.
upward tilted in common language, it's tilted
Okay.
upwards, right? So that's
Yeah.
convex. So concave is the other. Okay, let's type concave. So concave function. You see this, right?
You're right.
Yeah, this is concave.
Yeah.
So you want to optimize a convex function over a convex set, subject to a convex set. That is a convex optimization. So let me type that in. Yeah. So most of the problems can be, well, you didn't ask me the question that I wanted you to ask, which is, you want to take a guess?
Hello.
Yeah.
Can you repeat that? I couldn't get you.
You didn't ask me the question that I wanted you to ask. Can you think of the question that might seem obvious at this point?
Hello. Hello. I can't hear you.
Okay. So you didn't ask me
Hello.
why convex, right? I mean, why convex? What's so special? Why not log or any other function like that? What's so special about convex? So the thing about there are. Am I audible?
Yeah.
So the thing about convex functions is that they have properties, and previously people have proved this, wherein under certain circumstances they give an optimal solution of sorts.
Okay.
Hello?
Hello. Hello. Yeah.
Yeah. So yeah, that's pretty much it. So the technique of optimization is something like this. You have a standard form, you have a convex function like this, and your idea is to, let's say, minimize this function subject to G and H. Okay, subject to, not show that ST. When
Okay.
they say ST, it means subject to.
It's sure. Yeah, yeah. Okay.
Okay, so
Yeah.
convex optimization is the constraints are a convex set,
Right.
and the function is a convex function, and you try to
Okay.
minimize or maximize that.
Okay.
Okay, and when
Yeah.
you do that, you will get a point which is sort of what we call optimal.
Okay.
And people previously have studied that, and they have found that under these circumstances they will be optimal.
Okay.
So to prove optimality, you have to prove that the function is convex.
Okay. Okay.
Yeah, yeah.
Yeah.
So this is very much involved. Every machine learning algorithm has some aspect of optimization built into it. So
Okay.
broadly, statistics and optimization would constitute machine learning algorithms.
Okay. Okay.
Okay. So you have
Yeah.
any other question apart from
Uh,
this?
how is artificial intelligence different from machine learning?
Oh, okay. That's a good question.
Yeah.
So let me take some. Let me take some evidence for this. Hasty. Okay. Oh, this is a paper. This is a paper. So basically, if you're able to build a, I think it's a category of machine learning techniques, but then you build a network of sorts, and there are concepts like back propagation, which are pretty much related to AI. It's a let's say it's uh,
Okay.
AI techniques. There's nothing called AI in itself. Well, what is AI? There's no definition like that. But then you can broadly come up,
Okay.
string together. You cannot come up with anything, but you can probably string together some definition which is not universally accepted, but accepted in some quarters, just for the sake of simplicity and as a matter of fact. So
Okay.
these back propagation, all these techniques are AI related. And if you build
Okay.
a ML algorithm over a network which is sort of distributed, it becomes an AI technique. So all of
Okay.
statistics, some people, use it interchangeably, wherein they call all techniques related to statistics, machine learning, and these modern network-based distributed systems as AI techniques, which isn't the case. I mean, isn't
Okay.
really the case. But so this is like a standard textbook. That this is something that I would highly recommend people take a look at. And
Okay.
so, what's the name of the book? It's not called AI book, right?
Yeah.
You're able to see the book.
Statistics. Yeah. Yeah. Yeah.
Yeah.
I can see it.
There's no word called AI here, but
Yeah.
this is probably the best book there is on this field in the whole field.
Okay.
Okay, so
Yeah.
neural networks comes as part of this chapter. So if you're talking to a theoretical person, you would probably not ask these questions, saying, "Oh, how is AI different?" I mean, it's a
Yeah.
very it's a difference that is stated often by reporters and not people who work in the field.
Okay.
Okay, are we clear on that?
Yeah. Yeah. We're clear.
Okay, so for example, I'll just give you another example. So this guy, right? So he was a lab mate of Bharat, and let's say he's a faculty in CMU.
Okay.
So if you look at his papers, recent papers on ranking, let's say, he's in. So do you accept the fact that he's in machine learning department? He
Yes. Yes. I
says
do.
he's
It's
okay.
in machine learning. Yeah.
But the thing is, if you look at his papers, right?
Mm.
Let's take selected papers on crowdsourcing. Yeah, that's something that I'm familiar with.
Okay.
Where is not this one? Pairwise compare. Yeah. So if you take a look at this, This is pretty interesting work. But what is fascinating is the word machine learning, or even for that matter, the word artificial intelligence doesn't come here.
Yeah.
So see, this guy is in machine learning department. He's working on a specific problem with other people who are statisticians, right?
Right. Yeah.
Okay, so what he's basically trying to say in this whole article is you cannot come up with a score for scoring anything. Let's say you're scoring teachers' performance. So there
Right.
will ideally be a score-based technique wherein like you teach this well, you get this score. You number of people who passed your math exam, you will get these many points, and you add up all these points and you rank them. Uh, you rank them on a number line, and that'll give you the ranking order. What they say here is that is not the way. What they specifically say is you have to have comparisons individually. Okay. So,
Okay.
and in no way in this entire article do they mention. Wait, let me check this.
Yeah.
Yeah, it's barely mentioned. It is published in one of these. It's the techniques are more like ranking techniques. Do they use parametric techniques or non-parametric techniques? These are things that are discussed, but nobody uses these buzzwords. It's usually
Okay.
people outside the field that use these buzzwords.
Okay.
Okay. So I think this is a good example because he belongs to a department called machine learning department. If you look at his CV, which is quite interesting too. He studied in School and he studied telecommunication distributed systems, and then he started writing papers. And this guy is a major person, by the way,
Right. Yeah.
So that goes to prove that you had to solve specific problems, and the sum total of all these problems can define a field called machine learning and AI. There is no one monolithic thing called AI.
Okay.
That is the point I was making. Any other questions at this point? We'll probably wind up because I think you should. You wanted to go at
6. Yeah. Okay. One. So where is you've given examples on where machine learning is implemented, but what are the fields what are the applications, like in what fields is machine learning applied?
Oh, okay. So I think broadly every field. Okay, to be very precise, anywhere in which you have to improve any field which has some sort of mechanism wherein you have to improve the performance of a system over a period of time given the circumstances. So that is a general statement that is applicable to literally every phenomenon there is. But if you are able to measure it, and if you're able to put, like for example, maximizing profit given the market size. So say I'm selling a unique product and I'm let's say a monopolist. Okay. Meaning like I have a monopoly over the market, and I want to find out the effect of let's say 2 more players coming into the market. Okay. So even anything that in which there is a system in which you have to maximize or minimize something subject to some constraint, or you need not have any constraint. So all these will be examples of machine learning. So improving health, improving, in specific examples in which these techniques have been used and have had positive impact, computer vision problems, voice to text to a certain extent. These are all problems that have shown positive impact, which is significantly higher than previous techniques which have ever achieved. So even deep learning comes into AI. So I hope you didn't ask me. So deep learning is like some version of AI.
Okay.
So literally anything in which you have an input and an output, and you want to be able to increase the efficiency of the system given some constraints. That is a candidate for ML technique. Okay. So any questions? We'll probably wind this out. I hope the things that are conveyed, things that were conveyed in this were helpful to a lot of people. So,
Okay.
this is what we will cover broadly if you were to get into
Okay.
this. So I'll just give
Okay.
you, this is the plan, and we'll see how that goes.
Okay.
Okay?
Yeah.
You can probably give this to people who are interested. That should be sufficient. Or
Okay.
maybe ask them to come to the video and check it out themselves. That'll be better.
Okay. Yeah. Okay. So will you be posting this on YouTube?
It's live.
Oh, it's live on YouTube too?
It's live on YouTube right now.
Oh, okay. 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 Fine.
So you want to say hi on the video, you can probably do that.
No. No. It's
Okay.
there's no power here, so it's completely dark.
It's okay, no problem.
Yeah.
So
Okay.
this is already live. Okay.
Okay. Yeah. I'll share this. I'll share the link to other people who are interested.
Share the YouTube link. That'll be better.
Yeah. That link. Okay. Yeah.
Thanks everyone for joining. Thanks everyone who will watch this later, and hopefully this conveyed a lot of information in terms of the importance of the field and why this is the right time to know about this field. Thanks a lot for joining. Thanks, Ria, for conducting this.
Yeah.
Take care. Good day.
Good day.